students, today let us learn development of lateral surfaces of a cone. So go to File, New, Drawing, OK. Select A4, switch off display sheet format, custom sheet size 297, 210, click OK. Make sure the units is mmgs. The scale should be 1:1. Right click on sheet 1, properties, first angle, apply changes. Already I have copied the question from the question bank. I'll paste it here. So this is the question which I copied. So let me read the question. A right cone of 55 mm base diameter, 75 mm height, stand on its base on HP. It is truncated with its surface inclined at 45 degrees to the axis and lying at a distance of 40 mm from the apex. Obtain the development of lateral surfaces of the truncated cone. So let us draw this. The very important parameter here is the definition of the solid. So it's a cone, diameter is 55, height is 75. The section plane makes an angle of 45 degrees with respect to the axis and it is at a distance of 40 mm from the apex. So this is the data which we get from the question. Let us solve this question now. So go to sketch, line, draw a line here, make sure it is horizontal. Go to circle, draw a circle, smart dimension, 55 mm is the diameter of the circle. Now you go to line, from the center. How do I get the center is place the cursor on the circumference of the circle. This will get highlighted, center. From center to one of the node, you draw a line. So it's radial line. So what I will do is I will be using circular sketch pattern to create a pattern here. So go to circular sketch pattern. Click here to mention the center point on which this line should be rotated. This is the center point. So as soon as you click here, it will get updated. You can see here X and Y coordinates have been updated. 360 degree, yes, complete 360 degree. The number of parts I want is 8. Entities to pattern. This is the line which I want to create a pattern. Click OK. So this is how I get 8 parts. So to remove this 8, you can just click on this 8 and delete it. Only that 8 will get deleted. So next, how do I draw the front view now? So go to line, drop projectors, make sure it is vertical. The relation should be vertical. You can see the next to the cursor is vertical. Okay. Then you remove this extended line by using power trim. So as you can see here, power trim is active. I draw. Next, I'll go to line. I'll draw a line of, they are given in the question, 75 mm. Diameter is 55 and the height is 75. So that I mentioned. Next, connect a line from the apex to the base. So these lines are called end generators. So whenever you see a cone, it's a curved surface, whereas you can see only the outline. These outlines will always be thick. Don't forget to make the base also thick. The base will also be thick. Similarly, the circle will be thick. This is before section. Before sectioning, this is how the cone will appear. And this length, we call it as slant height. You can see here 79.88. This is the true length of the slant height, which I am going to use to find the sector angle as well as for the development. Right? Now let me construct the section plane now. In order to construct it, they are given in the question that it is at a distance of 40 mm from the apex. So I will draw a line here approximately more than half of the length. Select this end point, give the distance as 40. Then go to line. From here, draw an inclined line. Okay, draw an inclined line. Dimension this angle. Angle should be 45 degree. Yes, it is 45 degree. Then use extend entities. Extend the same line. Okay, this is the section line. So wherever it is passing through, that portion, this portion will be removed. Now how do I do that is by using trim option. You can trim this, and I can redraw it since I have the apex. So this portion, why did I made it thin? Because it is removed and this portion is retained. So select this line. How do I represent the section line is by making it chain type. But the axis line will also be chain type. So in order to differentiate the axis line and the section line, we need to make the section line ends thick. So there is another option in the line type where I can make use of the thick and thin. Means I can select this line, I can go to this and I can make it thick and thin. You can see the ends are thick, but it's not so prominent. That is why what I will do is, I will not use this option thick and thin. I will maintain it as chain type, but I will use lines here of approximately 5 mm to 7 mm. Not a problem. So we make lines of around 6 mm or 5 mm. Select the line using box 1 mm. Now you can see the ends are prominently seen. Why this has to be made? Because the representation of section line is such a way that the ends are thick. That is why we differentiate between axis line and the section line. Now I should show the section plane also. For that I'll go to note and I'll use this note option, caps lock on capital S. But I don't want this bent line. Click on this. You'll get straight leader. Click on the straight leader and put it here. So make sure the arrow should always be perpendicular to the section plane, right? Similarly here also I should do the same thing. So how do I do that is, I'll use another option called balloon. So any option you can use, but the representation should be done. Okay, you can see the default is it is having a circle as well as one. You can remove that. Just select this and go to circular, go to none. You can see circle is removed. Now I want a text. Select text, type capital S. Okay, both will give me the same output. Whether I use note or whether I use balloon option, I'll get the same section plane, that is yes. Next, what I'll be doing is, I'll be using this length, that is 79.88, to find the sector angle. So when you cut along the end generator, when you open it, so you'll get an angle theta. That angle theta is called sector angle, because this when I cut along the end generator, when I open it, I'll get sector of an arc. So that sector of an arc will have an angle theta. That theta will be found using a formula. Theta is equals to R by L into 360. That I'm going to use now. Before that, I'll do the notations part. A, B, C, D, E, F, G, H. Okay. So let me drag it. Let me place it precisely by zooming in. Zoom in and place. Then only it will be precise. A, B, C, D, E, F, G, H. So these are the 8 parts. Similarly, I should name the apex also, O of O1. So O will be the apex, O1 will be at the base. So O1 represents the axis. Similarly, go to note. This is O dash. Similarly, I should name the remaining points by looking at the top view. I can name it easily. So first point is A dash. The second one will be B dash in bracket H dash. The third point will be C dash in bracket G dash in bracket O1 dash. The fourth one will be D dash in bracket F dash. Similarly, the last point will be E dash. Okay, this is A, this is B in bracket H, this is C in bracket G, so C dash in bracket G dash, D dash in bracket F dash, like that we need to name. So let me place it in the respective places so that there is no confusion. Okay, so this is how we tend to do it. Okay, after the placement, next we'll go to the formula now. Note, click, select the font symbol, theta. How do I get theta is, make sure caps lock is off, type Q. Q stands for is equals to, make sure you press right arrow key to come out of symbol. Now Century Gothic is active. Capital R by L into 360 degree. Degree symbol is here, you'll get insert symbol, that is theta. So that degree symbol you'll get. So the formula which is used to find the sector angle is theta is equals to R by L into 360. R is the base radius, that is 55 by 2. L is the slant height, which is 79.88. Right? Let me complete this by substituting the values. Substitute the values of R. 0.5, 55 by 2. Where is 55? You can see here it is 55. It is 55. Still the font is symbol. Change it to Century Gothic. Century Gothic is the default font. So 27.5 divided by L, 79.88. 79.88 into 360 degree symbol. This is where you'll get. Press this. Next, theta is equals to Control C, Control V. I'll use copy paste so that I need not insert that symbol again. Next, what is the angle? The angle is 123.94. Use calculator and find this. Okay, you'll get 123.94. So 123.94 is the sector angle. The sector angle is 123.94. Well, let us insert symbol called this degree. Okay, this angle we use it to get the development, right? Okay, now let us use this sector angle as well as the slant height to complete the development. So sector angle is 123.94. Now go to line, draw a line of length 79.88. This 79.88 is the true length of the end generator. 79.88. 79.88. Click OK. Now you can see the line, right? This is 79.88. I will use circular sketch pattern. Click here. This is center around which this line will be rotated. How many I want? I will type 9. I will show you what is the difference between 9 and how much white is correct. The angle is 123.94. The angle is 123.94, and the line which I want is this. But this positive will go in the other direction. So you can see here the arrow mark. This is pointing upward. That is, when I click OK, all the parts will be divided here. I want it below. So I should type minus 123.94. When I type minus 123.94, you can see. So it will start here and it will end here. Now I'll say OK. Once you say OK, you can just observe whether it is 8 parts have been created or not. Whether there are 8 parts, just check. 1, 2, 3, 4, 5, 6, 7, 8. So 8 parts are there, but if you count the number of lines, 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 lines. That is why I gave 9. Otherwise, I would have given 8. If you give 8, what will happen is you'll get 7 parts. So be careful while mentioning the parameter here. Especially this parameter 4. Okay, right now default is 4. But don't give 8. Give 9 because it is inclusive of this line. It is 9. Inclusive of this line. That's why. Don't make this mistake. Next, I'll go to arc. I'll go select this as center. This as a start point. And I'll draw the arc and trim this extended portion. This is the sector, what I was talking about. The angle between these two lines will be 123.94. You can always dimension it and keep it. So this is the development before sectioning. Before sectioning, it appears like this. Now after sectioning, how it appears. So what we have to do is, we have to present all the section points on the development. How do I present all the points on the development? So let us go to the front view, top view, and let us assess how many section points are there. So as you can see here, the intersection of section point with the end generator. Let us drop the projector. This is where exactly it is intersecting in between O dash and A dash. So let me drop the projector onto OA, and it should be vertical. Remember, it should be vertical. So this is where exactly the first section point is. Similarly, there is an intersection of section plane exactly at this location. Okay, exactly at this location it is intersecting. If you are not getting intersection point, you can trim it and you can redraw that line so that you will get the point easily. Now I can draw a line, and this line should coincide with this H. Okay, then the same line should be extended towards B, because OB and OH both are overlapping in front view. Okay, so you'll get first section point here, second section point here. Right now, next comes the section point on O dash and C dash, exactly here. So how do I drop the projector? If I drop the projector, it will lie on the same line. So for that, what we do is, we follow the constructions. Drop a projector on the slant edge, then drop a projector on O dash, E dash, that is OE. Make sure it is vertical. Next, we go to arc. Select this arc, rotate it. Select this arc, rotate it, trim it. limit. So these 2 points we have obtained. What basically we are doing is we are trying to transfer this length here. That's all. We're not doing anything here. We are transferring this length here by using the construction. So I got 1, 2, 3, 4, 5 section points I got right now. Still there are 3 more. So where are those 3? Here. There is one more section point here. I'll go to trim. I'll trim this line because I'm not getting intersection point. I'll draw it. Now I'll draw the projector now from here. That is from onto OD and OF. First I'll drop it on OF. I'll trim this and I will extend this onto D. Make sure the projector is always vertical. Don't click arbitrarily. Next, the last point, that is on O dash E dash. We need to put it on OE. So totally we get 8 section points. Let us name that 8 points now. Go to note. 1, 2, 3, 4, 5, 6, 7, 8. Let me place it precisely. This is the first section point. This is the second section point. This is the third section point. This is the fourth section point. This is the fifth section point. This is the sixth section point. The seventh section point is here, and the eighth one will be here. So by looking at this, I can name the front view also easily, right? So I'll go to note. I'll type this as 1 dash. Similarly here, this point would be 2 dash in bracket A dash. 2 dash in bracket A dash. Where is that point? Exactly here. 2 dash A dash. So similarly now next 3 dash and 7 dash will be here. So 3 dash in bracket 7 dash. 3 dash in bracket 7 dash here. The next point, if you observe, look at the top view and 4 dash in bracket 6 dash. This is the point, 4 dash in bracket 6 dash. So type the empty space, then you can drag it and place it. 4 dash 6 dash. The last point is 5 dash. Okay. So now let us place it. 4 dash 6 dash here, 5 dash here. Okay. So this is how we get in front view. That is section points. These points has to be presented on the development. So on OA I'll get 1, on OB I'll get 2, like that. 3, 4, 5, 6 I need to plot it. How do I do that? First let me name this points. How do I name it? Similar to the naming how we did in the solids, here also we should do the same thing. O, this is A, B, C, D, E, F, G, H and A. Okay, so these are the end generators. We have cut along OA, that is why on both the sides we get OA. So we have to mark 1, 2, 3, 4. So if you observe carefully, only O dash 1 dash and O dash 5 dash are having true lengths, because already I have told you, any measurement whatever we do, it should be having true length. There should be no apparent length, right? So in order to do that, we need to transfer all the points onto the true length. For example, if I want to measure 1 O dash to 2 dash, I need to present it on this. If I measure the distance, for instance, now I want to measure the distance from 5 dash to O dash. So this is the measurement which I get. That is 31.17. Let me drag this. Let me drag it here. Similarly, if I want to measure the dimension of 1 dash, see, O dash to 1 dash, this is the dimension. That is 67.27. Okay. Similarly, if I want to measure O dash to 2 dash, this is 57.52. Click OK. Always remember, the smaller dimension should be inside, the bigger dimension should be outside. Similarly, if I want to measure the dimension from here to here, it is 42.60. So all these dimensions plays important role now. Why? Because we have transferred it onto the true length and we are measuring it. Very important. None of the dimensions should be having apparent length. All, if you observe here, every end generator will be having 79.88. If you measure directly from here to here, this end generator will not be 79.88, it will be much lesser than that. That is why don't measure it directly. Transfer it onto the end generator which is having true length, then measure the length, then you will get it, right? Now let us take one at a time. So the first point is 67.27. So go to arc, 67.27, approximately 67.27, draw an arc, give the dimension for it. This is 67.27. The same kind of arc will be there on the other side. Why? Because both are having same points, OA. So repeat the same thing on the other end. Approximately you take it up to 67, draw an arc, go to smart dimension, measure it as 67.27. Okay, this completes the first section point. First section point is over. Now second section point is having 57.52. Same thing you repeat it. Select the center, 57. So approximately 57. Draw an arc. If you want to repeat this, again you can repeat, because OB and OH will be having the same radius. So you can draw it approximately. Later you can dimension it. So OB, OH over. Similarly here, the third one will be having 42.60. So select this, 42.60. First point is this, that is on OC. Then once again on OG. Select this, on OG, this. Okay. Later I will dimension and I will try to make it accurate. Next, the fourth and the sixth point, okay, which we have not dimensioned. So just take this point, project it here, trim it, measure it. Let me drag this a little bit so that there is sufficient space for my fourth point. 33.83. This is on OD and OF. Okay, so go to arc, approximately 33 mm. So take 33, approximately, draw an arc here. Same thing, you repeat it on the other side also. Okay, now the last point is 31. So that is on OE. Okay, draw an arc. After drawing all this arcs, now it's very easy. Select this. The second point is 57.52. 57.52. Similarly here, click OK. Here, this one is also 57.52. 57.52. Okay, so this B and H is done. Next is C and G. So this is OC and OG, 42.6. Okay, similarly this is 42.6. 42.6. Click OK. This one is 33.83. 33.83. Similarly, this distance is 33.83. Okay. Last one. The last one is having 31.17. 31.17. Click OK. 31.17. Now after this, I have to join all these points. Since it is a cone, I cannot use straight line. I should use spline tool to do this. So I will go to trim and I will trim this portion so that I will get the intersection point correctly. Otherwise, I will not get intersection point correctly. That is why I will use trim option. Now I will go to spline, select this end points. You can see end points. Click on this points. Okay. After selecting the last point, press escape. When you press escape, the curve will be created. Now you can select this curve and make it 0.5 mm. Similarly, this outer curve should be 0.5 mm. Here, this portion of the arc should be, end generator should be thick. So trim it and redraw it. Why? Because if you select that line, entire line will be selected. So that's why we want a portion of the line to be selected. That's why I have trimmed and I have redrawn. Okay, so this is how a cone will be created. You can remove multiple dimensions. For example, this can be removed, this can be removed, this can be removed. Like this, you can minimize the dimensions. Let some of the dimensions remain. So you can remove this also. You can drag this up. Let us go to the top view. Let us complete the top view. How do I complete the top view? Is by going to spline. Select this, 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 select this. So this line will be thick. This line will be thick. So you know about the XY line VPHP, right? So XY VPHP you need to place. So don't forget this. In all the problems you have to mention whether you have used first angle or third angle. Because of that case we have to mention. How do I extend XY line? Very easy. Go to sketch, draw a line here, go to X entities. It will extend up to this boundary. Okay, so like this you can extend XY line also. Okay, any doubts, any questions are there, you can post it in comment section. Thanks for watching.